welcome back my friends. I am Raghunandan Sengupta teaching this total quality management course, and welcome to this third lecture, each lecture being of half an hour, and this is a total 20 hours program. Again to recap, even though the concept I have already mentioned, so they would be after each week they would be assignments, so there will be total of 8 assignments and one final semester examination. So, continuing the discussion with quality, its matrix and characteristics. So, this is now the discussion will take place about the characteristics of quality. So, no two products are ever identical. So, obviously, there would be variability, like say for example, if you consider a group of human beings, so the heights are different, so there would be variability. If the weights you are considering, there would be variability. Obviously, it does not have any implication for the quality as such in general, but I am giving these examples. So, say for example, if jam bottles are being manufactured or sauce bottles are being manufactured, or say for example, you are filling up tins of Amul Taza milk, or if you are trying to fill up Tropicana juice Tetra packs. So, obviously, there would be variability in the weights. So, whatever characteristics you are trying to measure in the quantitative sense for quality would have a level of variability. Whether the variability is very high or low, that is a different question, but there would be variability. Consider these examples which I gave, and added to that consider these examples. The thickness of blade of a fan between two flanges would be different. The orientation of the blades of the fan may be different, because obviously they are all manufacturing processes. There would be mechanical machines being utilized, there would be human errors, there may be machine errors, white noises, whatever they are. So, for all these reasons there would be variability. Customers may not accept products if the variability is very large. So, if you remember, if the variability is very large, it basically has an adverse effect or negative correlation with quality, which means quality would go down. Hence, the customers would not be satisfied with the level of quality for that product or the service. Sources of variability include difference in the materials, type of materials which are being used, the type of manufacturing process which you are using, the difference in the performance and the operations on the manufacturing unit which are being manufactured. It may be depending on the temperature, it may be dependent on the color, it may depend on the humidity, or say for example, many things which basically may affect the variability and make it large such that it will have an adverse effect on the quality. Quality characteristics are also related to specifications, which are the desired measurements of the characteristics whether they have been met. If you are trying to basically build, coming back to the example of the tie rod or the transmission line, if the actual length should be 12.5 feet, obviously it would mean that until unless it is 12.5, the tie rod cannot be utilized in the mechanical sense for basically passing on the transmission power from the engine onto the gear system of the truck or the LCV or the car or whatever you are manufacturing. A value of measurements and that correspond to the desired value for the quality of the characteristics is called the nominal or the target value. So, if you remember the example which you are talking about, the products of the transmissions being supplied by customer 1, which was the US company, and customer 2, which was the Japanese company, and this was the example we considered in lecture number 2. So, in that case obviously, as mentioned by the last point of Jack Welch, which means that even if the target characteristics of the quality implication which you are trying to measure in both the cases was same, yet the variability for the Japanese product which was customer 2 was much more less with respect to customer 1, which was the US company, such that if which would basically have an implication on the variability, and again coming back to the same point, variability being high would mean quality level characteristics are much low. So, this target value is basically the value which you want to achieve when you are trying to manufacture this product. So, considering the example of the tie rod, the actual target value is 12.5 meters, what I mentioned, or 12.5 feet, whatever it is. The values which I am mentioning may not have any actual practical examples, but what the values in the numeric sense would give you an idea that what are the target values, and the characteristics of the overall product would be to basically adhere to both the numerical characteristics of shape, size, scale, color, whatever it is, based on which I am trying to utilize that product. Or say for example, if the quality of the cloth which I have purchased, or the quality of the garment which I have purchased, and if it is woolen garment, if basically the quality of the wool is very poor, of poor quality, obviously it mean that with very few washes the level of the quality or the level of usage of the wool garment would basically decrease, which means the durability is very low, which means the variability would have a huge implication and a negative implication on the concept of the quality for that product. Now, we will be utilizing and meeting for the first time few characteristics in the quantitative sense, and you will see these characteristics in the quantitative sense would be appearing time and again when we discuss the quality control charts, the X bar charts, the P charts, the R charts, and so on and so forth. So, let us at least spend some time in understanding this quantitative concept in a qualitative framework, such that when we actually do the problems, they would become much clearer to you. So, again I am saying that with a notion that we will first consider the qualitative aspect of the quantitative terms, and then later on when we will see that as we solve the problems, we will be able to understand them in a much better sense. Now, as far as I can recollect, in figure 1.2, that is where we consider the target value, the variability, and we measured what was the metric along the x axis and along the y axis. If you remember, we measured the relative frequency of the probability. Now, they were, if you go back to the slides or go back to the lecture, there were two other vertical lines on to the right and to the left of the target value. They were basically given as terms names as UCL and LCL, which is basically the upper control limit and the lower control limit, to which we will now discuss and make it much clear for the audience to appreciate what actually UCL and LCL means. So, UCL or USL, which basically means the upper specification limit also. So, these words would be utilized interchangeably. So, do not worry about that. So, UCL also would mean USL, which is the upper specification limit. It means the largest allowable value for a quality characteristics what we can measure and what we are allowed to basically measure, and basically see to that the characteristics of the quality being measured in the quantitative sense does not over exceed that would be known as the USL. And the counterpart on the left hand side, that means if you are looking at the graph with the middle value being the target one, and as you go on to the right hand side of yours, the value keeps increasing, and if you go on to the values on to the left, the values decrease. So, obviously, the value of LSL which or LCL, which is the lower specification limit or lower control value, would be on the left hand side. So, the second point means the smallest allowable value for the quality characteristics is called the lower specification limit, which would be on the left hand side, and try to recapitulate figure 1.2. Non-conforming products would be the products which do not meet one or more of its specification for which it has been designed or made. Consider this: if the heater is not able to heat the room, or if the AC is basically not able to cool the room, obviously it means it is not able to function as per its normal standards. So, obviously there would be non-conforming products based on the characteristics for which the products have been built or designed and have been made. A non-conforming product is also called a defective one, as it has one or more defects based on the level of quality characteristics which you are going to study or which we intend to study for that product for which it has been designed. So, a defect is the non-conformations to the specifications. It may be related to color, it may be related to length, it may be related to weight, it may be related to height, it may be related to texture, it may be related to, say for example, pH scale. Consider you are trying to basically manufacture a chemical. So, and the chemical and consider is a fertilizer, and you want the pH scale to be absolutely neutral. In that case, obviously, if the characteristics of the fertilizer is not as per the pH scale, it is basically more acidic or alkaline, it would mean the actual characteristics would be as per the non-conformance of the product for which it has been designed, and it would be called as a defective product. Or say for example, you have purchased a cloth and to be used during the summers, and you thought that it should basically be able to to really give you the comfort considering the very high humidity or high temperature it is, and if the type of the cloth is of terylene type or terracotta type. So, obviously, you would mean it would not be able to soak the overall the sweat of your body, and it would not meet the actual quality characteristics for which you have purchased the product. So, obviously, it would mean a defective product or non-conformative product. Examples to continue this would be consider the blade of the fan. So, let the length and the thickness be of two quantity which we are trying to measure. For the length, say for example, the target one which is the middle line, or say for example, considering this is a normal distribution, it would be the mean, median, mode, whatever we say, it is 30 centimeters. And if we consider the normal distribution to be true, which may not be true in many of the examples, but we will try to utilize the normal distribution for our general studies. So, obviously, it would mean the USL and the SLSL or the UCL or the LCL, which are corresponding to the upper limit and the lower limit, are equally dispersed onto the right and the left, because it is a normal distribution. So, obviously, it would mean that if USL or UCL is 32 centimeters, where the target value is 30 centimeters, then the corresponding value of LCL or LSL would be 28. So, if I draw this curve in a very simplistic way, with the mean value being the target. So, this is the normal distribution, the mean value being 30, which we have measured, the LCL or the USL, oh this is the UCL, sorry, UCL or USL being 32, and the lower control limit or the lower support level, whatever it is 28, which means the differences are 2 centimeters here, 2 centimeters here. So, obviously, these 2 centimeters which you are considering as the LSL and this USL need not be plus 2 or minus 2. It can be, say for example, plus 4 and minus 4, but the level of difference from the central value or the target value would depend on what you are considering as the variability or the actual dispersion of the distribution based on which you are measuring. I will come to that later on. So, it would mean, considering the example we have considered of a target value of 30, upper value 32, lower value 28, a blade having length between 28 centimeters and 32 centimeters is acceptable. Say for example, if you consider the example of consider the actual HP of a motor, it is rated, say for example, 200 HP, and the overall utilization is such that if the motor is between a length of about value of 210 to say for example, of 190 HP, you will basically consider that motor as conforming to the actual quality characteristics. Or say for example, you are basically making a special type of paint to be utilized in painting a room, and in the grade of pink is say for example, between plus and minus whatever level of value of utilization of measurement of paint you are utilizing. If it is basically conforming to that, you will utilize that paint in painting that room. Or say for example, you are trying to basically utilize, as coming back to the example of the fertilizer, if the pH scale actual target value is neutral, which is 7, and if the values between which you can utilize is 7.5 and on the other side is 6.5, then you if all the fertilizers are within that range of 6.5 to 7.5, you will say that they conform to the characteristics of the overall utilization of the fertilizer, and use them to as conforming products, and the other products which are over 7.5 and below 6.5, you utilize say them they are actually non conforming to the products. To consider the example further, for thickness of the blades we consider the target value of 10 mm, again consider the central value to be 10 mm, the USL or the UCL is plus 2 with 10, which is 12 millimeters, and the LCL or the LSL is 10 minus 2, which basically comes out to 8 mm. So, all the products which are within this range of 8 to 12 are acceptable and considered as conforming to the level of quality characteristics which you have assigned to them. So, this value of LSL, USL or the upper value and the lower value may change. Say for example, it may become 14 in the second example, and the lower value may become 6, which means 10 plus 4 is 14 and 10 minus 4 is 6. So, in that case they may conform to the characteristics depending on what you have preset as the values of the upper control limit and the lower control limit. That would depend on the level of quality which you want that product to conform. So, in that case all the products which are outside this range of 14 on to the right of 14 and to the left of 6 would obviously be considered as defective product and not conforming to the characteristics of quality which you have assigned yourself to measure. Consider the examples further on. If a blade has length 32 centimeters and thickness 6 millimeters, then it is said. So, if you match with the length and the thickness, so continuing with that, if a blade has length 32 centimeters and thickness 6 millimeters, then it is said to be non-conforming, defective and has one defect for the thickness. So, obviously, it meets the characteristics of the length, but there is defect in the thickness. So, there is one level of defectiveness. So, consider the second bullet point as measured. Here if a blade has length 33 centimeters and thickness 9 millimeters, then it is said to be non-conforming or defective and has one defect, and the defect is with respect to the length. Because if you remember, the length target value was 30, plus value was 32, minus value was 28. So, this value is 33, 33 is being above the upper control value, but this 9 millimeter was within the range. So, it basically meets the characteristics from the thickness point of view. Considering the third bullet point, if a blade has length 34 centimeters and thickness 6 centimeters, so obviously 30 more means 34 means it is not conforming to the length, 6 means it is not conforming to the breadth or the thickness. So, hence it is said that it is non-conforming or defective on account for both the defects, because it does not adhere to the properties of thickness and length based on the upper value and the lower value for this example. Consider the last bullet point. If a blade has length 32 centimeters and thickness 6 millimeters, then it is said to be conforming to both the account of length and breadth. Hence, it is not defective and it basically meets both the criteria, not to the same level, but basically level word I am utilizing it beforehand, but I will come to that concept, that what is the overall concept of level to conformance later on as we do the problem. But in this example we see the fourth bullet point, it basically means that it adheres to both length and thickness, hence it is not a defective product. So, now with all the discussions about quality and what we mean by quality, the different dimensions of quality, what are the different type of characteristics of quality, how do you measure quality, what you mention as the target value, what is the upper control value, lower control value, and what you say as a defective items. So, having mentioned that, we will basically go through the brief sequence of history of quality. So, I would not be discussing much of quality as from the historical perspective, but give you the main milestone based on which quality has taken some jumps in those time periods, such that we can really say that the concept of quality and the level of quality and the study of quality has really taken a front seat at those milestones, as that quality has become as more and more integral part of our life as days have gone by. So, consider this chart. I have made it in a very simple chart, so that you can understand the year and what was the actual event which happened, which you can basically say that has great implications in trying to basically bring quality as the main focal point for the discussion for total quality management, which we are studying here. So, in year 1875, Frederick W. Taylor introduced the concept of scientific management principles of to divide the work into small concepts of works into smaller, more easily accomplished units. The first approach to dealing with this more complex products and processes was basically done in this year and in and around that. The focus was on more on productivity, how works could be broken down into small units so that you can increase the productivity. Later the contributions came from Frank Gilbert and Henry Gantt. So, Gantt was basically the person who proposed the concept of Gantt charts and so on and so forth. So, in the later part in the 1900s to 1930s, after the works of Frederick Taylor, Frank Gilbert and Henry Gantt, Henry Ford came up with his great concept of trying to produce manufacture car for the masses. So, basically Henry Ford was the main person who came with the concept of the assembly line, further refinement of the work methods to improve productivity and quality and basically to improve the throughput. Ford developed mistake proof assembly concept, self checking and in process inspection, but the problem was that because the demand of products was so high, people were even willing to accept not good qualities or products which are not conforming to quality. But Henry Ford can be considered a pioneer in this field, but because in that case quality was there in the scenario, but the level of sophistication of quality was not to that level which we now see nowadays after the work of, say for example, Durand and Deming, which we will consider later on. In the 1907 and 1908, AT&T began systematic inspection and testing of products and materials to find out whether they are basically conforming to quality or not. This I am giving as a sequence without going into the details of the discussion. In 1908, Gossett, who basically used his pseudonym as student, proposed the introduction of T distribution. T distribution is one of the main distribution which comes out as an offshoot for normal distribution. Those F distribution, chi-square distribution and T distribution. We will study T distribution later on, the T tests and all these things. So, introduced the T distribution, that the person by the name of W. S. Gossett, results from his work on quality control and Guinness Brewery, that means the brewery which basically manufactures beer. In 1915 to 1918, during World War I, British government begins a supplier certification program basically to adhere to the quality characteristics of the products which are being supplied to the armed forces and to the industry in Great Britain. In 1920s, AT&T Bell Laboratories again forms a quality department emphasizing quality inspection test and product reliability and product being conforming to the quality level. Duding at General Electric in England uses statistical methods to control the quality of the electric lamps and test whether they are basically adhering to the level of qualities or level of satisfaction for which the products were being built. So, here the products were the electrical lamps. In 1924, Shewart introduced the concept of quality control charts in an Bell Laboratory. So, based on the work of 1920s where they were being utilized to check how good or bad the products which were the electrical lamps which are being manufactured, Shewart came with the control quality chart such that they could be actually utilized such that the concept of statistics could be brought out in a very simple way such that could be utilized to understand how the process was going on, whether the process were adhering to the quality characteristics, and if there was not adhering to the characteristics of quality which they were supposed to do, how things could be looked into in details to understand where the problem was. In 1928, acceptance sampling methodology was developed and was refined by Dodge and Roming in Bell Labs. So, you will, if somebody at all is interested to understand the concept of supply chain and how sampling was done, Dodge and Roming came with the multi-stage concepts of two-stage sampling and so on and so forth, such that you can at least have a better look at the quality and such that the products for which the quality inspection were being done could be monitored in a much better way. So, there is a Dodge Roming plan, and based on that is for the interest of the people who are in statistics, this concept of sequential sampling and sampling based on different type of levels of sample size was also done later on. In 1931, Schwartz publishes the Economic Control of Quality of Manufactured Products, outlining statistical methods for use in production and control charts. In the 1946 and later on, the American Society of Quality Control is formed as the merger of various quality societies. The International Standards Organization, the ISO, was formed. Deming is basically invited to Japan by Economics and Scientific Services of the US War Department to help the occupation of forces in rebuilding Japanese industries. The Japanese Union of Scientists and Engineers, JOSU, is formed. And the last point which basically I mentioned in Deming, it happened in such a way that the person who was sent from US to basically build up the Japanese industry, the Japanese learned the tricks, came back after few 10 or 30 years, say for example in the 1970s, and see that what has happened to the overall Japanese companies, how they have captured the American market, be in car, be it in electronics equipment. And if you see, the same thing has happened for the steel industry, and as obviously there are other reasons of cost and so on and so forth, but the concept of quality was brought in by the Japanese in such a big way by Toyota, by Honda, that all the American cars were really almost wiped out from the American market, and the Japanese slowly took control of the automobile sector in USA. In 1948, Taguchi began the study of the application of experimental design, and we all know that Taguchi loss functions which were utilized and utilized in such a way that somebody could understand the concept of design of experiments and how they can be utilized in the study of quality and process quality control charts. In the 1950s, Deming begins education of Japanese industrial managers. Statistical quality controls are brought in a very big way in Japanese industry, and they are widely taught to Japan. Ishikawa introduced the cost and effect diagram. So, that based on this concept of Deming, which has taught in the Japanese industry, Ishikawa's diagram, they were utilized in a very big way to increase the productivity and the quality of the Japanese industries in a very big way. In 1987, ISO publishes, the international organization, if you remember in the last slide, publishes the first quality systems standard. Motorola Six Sigma initiative begins. So, obviously, or if you read later on, and we will discuss later on, Motorola was the person or the company which basically introduces the concept of Six Sigma, and how the concept of Six Sigma we utilize in a very big way to basically to reduce the level of non-conformity in the products and increase the level of quality. In the 2000, ISO 9000 and 2000 standards were issued. Supply chain management and supply quality became even more critical in business successes, and quality improvement activities expanded beyond the traditional industries, setting into force many of the use of the quality concepts in the areas like financial services, health. If you remember, I did mention the health services like hospitals and so on, doctors and so on and so forth. It also came up in a very big way in insurances and utilities as the services sector expanded, and industrial utilization of the products and the services basically took a forefront in trying to deliver the products to its customers. So, with this I will end the third lecture and continue with the discussion of total quality concept and how the concept which you are going to study really makes sense to all the three lectures we have already studied, and tried to give in a very qualitative feel of what is quality, what are the dimensions of quality, what are the metrics of quality, what do you mean by quality, what is robustness and so on and so forth, such that we can slowly utilize the concept of both qualitative plus quantitative in a much better light to appreciate that how quality can be brought into the picture both in the production segment as well as in the service segment to improve and understand that how things can be improved in a very big way in all the fronts. Thank you, and have a nice day.